Negative 3x plus 3 and 2x plus 2.
Negative 3x minus 3. Yes, that makes more sense. So if you just indulge me, I promise I do not want to take away your work time, but I just want to go through this with you so that when it happens to you, you'll know what to do. Because this one caught me off guard. So I'll just do the one that Brady said, and if I'm a little bit off on it, bear with me. But I think he said negative 3x minus 3, and then on the bottom we had 2x plus 2. So if you'd be so kind again, I'm just asking for 5 minutes and then I swear you can get back to work. But I don't want to really go over this again just because you're not paying attention. So again, it happens. And so what's the first thing we do with these things? Always factor. Like that's got to be just 100% commitment on your part is factor. So on the top of this, what can I pull out? Yeah. And what does that leave behind? X plus 1, right? Got to change that sign. And then on the bottom, what can we pull out? A 2, and then that leaves behind an x plus 1. So this is a pretty unique situation, and I hope I don't confuse you too much with this, but do you notice how the x plus 1s cancel, right? That's a big deal. Like you should have taken that away from yesterday's lesson in the last couple of days, is that when things cancel, that means there's going to be a hole there, right? Not an asymptote, but just a hole. So I'm going to take a quick moment and I'm going to cross those out. All that's left is this. And I'm not offended that you wouldn't remember this, but maybe you do. Do you remember from Algebra 1, maybe what kind of a line we graph when all it is just y equals a number? It's a horizontal line. And if it's just x equals a number, then it's one of the verticals, right? And I know it's a little bit confusing because it doesn't match the axis, but it does make sense. So like this equation right here is really just a horizontal line. So, most rational functions have asymptotes and curvy do's and all that stuff, like the plane coming in for a landing. This one, at the end of the day, is really just a horizontal line. I'm going to go over to Desmos real quick and just show you something. Um, I'm trying to be as quick as I can. So let's say that the top was negative 3x minus 3, right? And then the top was what? 2, or the bottom is 2x plus 2. And lo and behold, holy goodness gracious, look at what happened to my beautiful rational function. It looks like a straight vertical or horizontal line, doesn't it? And it is. What's the one thing, though, that a ninth grader or an eighth grader graphing horizontal lines wouldn't know about this graph? There's a hole, and we can't see it. And listen, I don't ding Desmos on much, but if I could ding Desmos on one thing, it would be that the computer never lets me see the hole. And where would the hole be? At -1. Because remember how we crossed out x plus 1s? If you were writing down this example, we crossed out x plus 1 and x plus 1, and the number that makes x plus 1 equal 0 is -1. And no matter how much I zoom in on Desmos, there should be a hole right there where I'm moving my pen. But I could zoom in for another hour. Honestly, it would stop me after a while, but I can keep getting closer and closer. If you've lost track, -1 is right there, and you cannot see the hole. So all we would do, and I know this isn't a graphing assignment, but all we would do to remedy the situation is we would just acknowledge and draw a little hole there, but the graph is still just a horizontal line. So let's go through and fill this in as if we were doing a Desmos problem or a delta math problem. So let's go through in order this problem. Does this function have a horizontal asymptote? It does. And it's interesting to say it because like a horizontal asymptote does not have to be something where a plane comes in for a landing. Graphs can actually hold on to horizontal asymptotes. So this graph actually, you could say the graph is its own asymptote. So there is a horizontal asymptote at y equals -3/2. Got it? Does this graph have a vertical asymptote? No. It had a shot, but when the x plus 1 canceled, then we had to say no. Knowing what you know, and again, I do see a few of you still listening, knowing what you know now about what the graph of this looks like, what is the x-intercept? There isn't one. You understand that now clearly, that there just can't be. A horizontal line never crosses the x-axis, right? That's a no-brainer. Is there a y-intercept? Where? At -3/2. Correct. Because that's what you get when you put zero in place of X. And listen, if there's no X left to put zero in place of, like, look at the thing I'm circling in green. If I said to you, put zero in for X, that can be really confusing because you're like, well, there is no X. So when we don't have anywhere to put a number, we just default to the numerical value of the function, right? Put zero in for X, the function doesn't care. It's like my value is still negative 3/2. And then finally, is there a hole? There is. There's a hole. And the hole is at the point -1 something. And how do we find the something? Again, and this is why I wanted to go over this with you, because it's kind of goes against what I taught you. I taught you to put that number in place of X's. But again, I'm going to say if there are no X's, you just default to what the function is. This is like an I don't give a crap function if there ever is one. This green circle is saying, do whatever you want, waste your time, go change X into 52. I'm still negative 3/2. Oh, you want to put a million in for X? Okay, go ahead. I'm still negative 3/2. Like I'll be here when you're done, right? So any Y value that we get is going to be negative 3/2. And that's where the hole would be.
Squared.
Yeah.
Negative 5x plus 2.
So what do we do?
Factor
All right, what's the top factor down into?
x minus.
Love it. And then the bottom,
Negative 5 times x minus 2.
you know, our existence is so much better when you just know how to factor. So thank you for that. And now we take note and start saying, okay, what are we going to do? What's the first thing? Right. So we're going to take this out, first of all. And I think that what I find beneficial is to just write the kind of new function somewhere just for use, because it's going to be what we plug stuff into. You don't want to plug stuff into the original one because it's more work. So, all right, so let's go through the list. We'll just go down the line one by one. Is there a horizontal asymptote? Nope. There is a horizontal asymptote at the point N-O-N-E. Oh, wait, that spells none. There is no horizontal asymptote. Why?
Oh, there's no
Did you say there's no X in the bathroom?
at the bottom.
There's an X on the bottom. It's right here.
Oh, I'm looking at the factor down one.
You need to go all the way back, I would think, to the beginning of the problem and just, this will be a sticking point, but not after today. You're good. Why is there no horizontal asymptote? Do you know the name of any like famous antiperspirant and deodorant companies or brands? What's a common one? Uh-huh. Okay, give me another one. Give me another one. Starts with a D.
Dove.
Well, I didn't see that one coming. That's a good one, but no. Oh,
Degree.
degree. Good. I just felt like talking about pit sticks. So yeah, degree. Listen, you better put this down in your notes that the way we determine horizontal asymptotes doesn't have anything to do with the 5s and the 4s, kid. It's the degree. You look at the degree. The degree at the top is 2 because it's x to the 2th. The degree of the bottom is 1 because it's x to the 1th. When the degree at the top is higher than the degree of the bottom, your function will not have a horizontal asymptote. There are 3 possible scenarios. Either the degree is bigger on the top, smaller on the bottom, none, or the degree is smaller on the top and bigger on the bottom, then it's at y equals 0. Third scenario is if the degrees are the same, that's where we kick it out and default to the numbers on the front. Got it? So there is no horizontal asymptote. Got it? Nice. Let's go to the VA, not the Veteran Affairs, but the vertical asymptote. Where is the vertical asymptote?
0.
Nope.
Is there is not?
Are you just guessing?
No.
There is none. I agree. Just the way you said it made me think like she's just guessing. I wanted to make sure you were sure. Why is there no vertical asymptote?
Is it because there's no x on the bottom?
It's because the number that would have made the bottom equal 0 right here would have been x equals 4. You need to right away flag 4, put him on your radar and say he's a bad guy. He makes bad things happen. But he's not an asymptote bad guy because he canceled. So he no longer lives to make an asymptote. He remains in our memories as someone who's going to later on make a hole in the graph, but he doesn't make a vertical asymptote because he's no longer there. He got canceled out. Right? 2 down, 3 to go. How do we find an x-intercept? That is correct. And so it's a very simple, like I don't mean offense when I say this, I just intend perspective. It's a very 7th grade question. What makes the top equal 0? Good. So therefore, there is an x-intercept at 5, 0.
X plus doesn't cancel.
Got it? Let's go on to y-intercept. How do you find a y-intercept? No. You make all the x's into 0. And in a case like this, I would just, again, mathematicians, we've all done the work for you to experiment. You're going to get the same answer if you use this to put zeros in place of all the x's, or if you use this or this. 100 out of 100 people surveyed said they'd rather use the one with the yellow in it, right? So if we just take that simple, dumb little simplified reduced function and we put 0 right there in place of x, what's 0 minus 5? And what's negative 5 over negative 5? So there's a y-intercept at the point 0, 1. You still with me? And then finally, we have to do the hole. And we know that there's going to be a hole because we had that cancel-y thing early in the problem, right? Yeah. So we know this much. The x-coordinate of the hole is 4. Because 4 is the number that would have made the parenthesis, the factor thingy equal 0. And how do we find the y to go with it for the hole?
Oh, shoot.
Same exact thing.
Oh, yeah.
Same exact one as what Brooklyn has? That's cray-cray. Totes. When you want to find the y coordinate of the hole, you take the x coordinate of the hole and you plug it back into the function post-reduction. I want you, the one that I circled in purple and yellow is our guy. Do you understand what would happen if you put 4 back in this one? Like up here, what's 4 minus 4? What's 0 times anything? 0. And on the bottom, it's undefined. Like it doesn't have a value. That's why the hole exists. That's why putting 4 in there isn't going to get you anything but frustration. You have to put 4 into a place where the trouble has been removed. This one over here. So you simply take where that red arrow is pointing and you change that x into a 4 because that's how functions work. You give it something, it'll tell you what the y value is at wherever you want it to tell you. So if you put 4 in there on the top, what's 4 minus 5? And what's negative 1 over negative 5? So there's your hole. And that is that. What's up, Brinley?
Yeah,
I'd love to. Can you just read me your function?
You want me to give you the design or do you want me to?
OG. I want the.
Yeah, negative 3x minus 3x plus 6 over 5x squared minus 6x.
Okay, so you pulled a negative 3 out of the top, I presume. And that would have left you with x squared plus x minus 2. So x plus 2, x minus 1. Is that right?
Yeah.
-1. And then your y coordinate is.
Is that?
So like, we know.
Let me slow down because I might have factored wrong. No, are you sure it's not me? Because I shouldn't be doing that kind of stuff in my head. If you
X plus 1 times x minus 1 and negative 1 times 1.
oh gosh, yes, that's no good.
Yeah.
Okay. Two. Wait, what do we have?
Yeah, so I think my factoring is good. And then let's talk about your bottom. If you pull out 5,
Plug in x's here.
does your bottom, Brinley, have 5
That's fine.
Y intercept is that's me.
Yeah.
Yeah.
So would you like to work through it again, or do you want me to
It'd be 0,
you want to do it with me? Okay, let's do it. So what's the first thing we're going to do?
0.
Let's go before that, because there's actually, let's get rid of those first. Let's clean house a little bit. And honestly, if you wanted to find the horizontal, then I got no issues with that. But I'm going to kill these and I'm going to kind of leave them around, but I like to mark them so I know they're dead. Because that's going to come back and play a role later. Okay, so now I'm ready for horizontal asymptote. Where is our horizontal asymptote? Yes, because the degrees were the same, we defer to the front numbers. Is there, Bryn, a vertical asymptote?
Oh, I know. Right. I put a
No.
plus 3.
Yes.
Good call.
Is there a number that, yeah, did you say 3 or no? Did you really say 3 or did you say no? Okay, well, I guess that's fine. So there is a vertical asymptote and it is at x equals 3 because the x minus 3 survived the cancel. So he's alive to make an asymptote. What is the x-intercept? Do you understand how to find an x-intercept?
Am I wrong?
Did you say -2? That's good. Yep.
Not that long ago.
So there's an x-intercept and we name it as -2, 0 since it's on the x-axis. And is there a y-intercept? And how do you find a y-intercept?
Like, you're the that.
That's right. And then just remember to use your post-reduction. You get the same answer, but so put 0 to get -6, 0, -3, -15. Good job. So it's at 0, 2/5. And then finally, let's cash this thing in. Let's get her done. We know there's a hole, so I'm not going to ask you. What is the x coordinate of the hole? Good job. And how are we going to find the y coordinate of the hole? Plug it into the post-reduction function. So 1 + 2 is 3, 3, -9. 1, 3, -2, -10. What'd you get, Bryn? Anybody need some help? Want to go through your problem together? Sure. Okay, so this is going to be a horizontal one. So we'll talk about y here in a second. So you have 5x + 10 over x + 2. What's the first thing we have to do? Starts with an F, and it's not my favorite version of the F word. What is it? No. Factor. Yes, bar none. We have got to dismantle this function as much as we can. You need to expose all of its parts and pieces. The reason being that we want to look for things that make 0. We want to look for things that cancel out. And we can't do that when it's all glummed up together. Factoring is the key. Step 1, without exception, factor. Okay. So the top can be factored by pulling out a 5. And if you pull out a 5, what's left on top? 5 times what? Correct. Now, this is kind of what I started class with, was this idea that sometimes you factor and you realize that everything quote unquote meaningful goes away. Like the variable x is what makes all this stuff exciting, and he's actually just going to go bye-bye. And that's going to leave us, when you cancel all of this stuff out, with a function that just quite literally says f of x equals 5. Are you okay? Are you sure? If it's hard to hear because of the talking, you're going to have to move, because I think that's an issue for you as you get distracted. I can't talk any louder though, so you need to come closer because they're going to keep talking about their math. So, are you with me?
Yes.
Okay, so we now know that we're dealing with a situation that isn't one of these asymptote kind of things. It's just a line, right? A horizontal line. So now we have to go through and work it out. So first one is there a horizontal asymptote? There are three things that you need to know about a horizontal asymptote. And at some point, you're going to need to memorize them. I understand that it's not yet, but it has to happen soon. There are three things. You have to look at the degrees. When you're looking for a horizontal asymptote, there are three things that can happen. And it has nothing to do with the 5 and the 10 and the 2. Nothing. It's the degrees of the x's. That's what we need to study for horizontal asymptotes. What's the degree at the top? It's 1 because it's 5x to the power of 1. What's the degree at the bottom? Because it's x to the 1. When the degrees are the same, then you go and you look in your notes and you say, okay, when the degrees are the same, there is a horizontal asymptote. And the only way to find the horizontal asymptote is to understand that it will be at the ratio of these two yellow numbers. That's the only time we're going to even give a rat's fat gadushka about those yellow numbers. We defer to them when the degrees cancel out and they can't have a say. So there is a horizontal asymptote, and it is at y equals 5 over 1, 5. There are three things that can happen with horizontal asymptotes. Number one is it can be at 0. Number two is there cannot be one. And number three is it can be there at the ratio of the leading numbers. In this case, there it is. Now on to the vertical asymptote. Is there a vertical asymptote? Let me ask you this. What makes a vertical asymptote? Okay, here's how you make a vertical asymptote. If you can make the bottom of a function equal 0, then you have potential that you found a vertical asymptote. Are you hearing me? So look at the function up there on the TV. This right here can be made to equal 0. You agree? That's a bottom. It has an x. And if I put -2 in place of x, what is -2 plus 2? 0. But here's the deal. -2 is not a horizontal or not a vertical asymptote. Why? Why does it go from being a vertical asymptote to a hole? Because it cancels. When you have something in the bottom that you can make equal 0 with an x, this is why factoring is critical. You have to then look upstairs and say, is there another one of me up there? And the x plus 2 that I've circled there he can be made into a 0 with -2. But this other one that I'm going to circle in red comes in and says, wait a second, look at me. I can cancel you. Therefore, the number -2 is no longer a vertical asymptote. It's a hole in the graph. So the answer to is there a vertical asymptote is no. There was a shot at it early when we saw that x plus 2 on the bottom. And then we realized, well, that x plus 2 just took a dirt nap. So there is no vertical asymptote. Vertical asymptote, there is none. The key for this is that you have to, at every step along the way, be jotting down notes or something that remind yourself of, okay, when I'm here, this is what I look for and do. When I'm here, so we have 2 down, 3 to go. The next thing that your computer is going to ask you for is the x-intercept. And what we do is we say to ourselves, how can we make, running out of colors here, yellow, how can you make the yellow expression equal 0? What could you put in place of x to make that equal 0? There isn't one, right? You can't because there's no variable. Therefore, there is no x-intercept. Do you remember how I started class with that horizontal line? You understand the horizontal line never has so here's the x-axis up here. A horizontal line just runs parallel, and so it never intersects with the x-axis because it's like going above it, but it's parallel, right? So there's no x-intercept. What's the y-intercept going to be? In other words, think about this. Think about this line. So this is the function. It's y equals 5. How do you graph a line y equals 5? What kind of line is that again? Horizontal. So I'm going to go up 1, 2, 3, 4, 5, and I'm going to graph a horizontal line through that point like this. When I phrase it to you like this, the question becomes a little bit silly. Where does that graph cross the y-axis? Therefore, we have a y-intercept. The y-intercept is at a point And the name of the point is 0, 5.
So then.
So y inter. What did you just call it?
Everybody's making fun of you over here. I don't want to.
Did you say asymptote?
Yes.
Holy Lord, son. So there is a y-intercept and it's at the point 0, 5. Here's what I would normally tell you. To find a y-intercept, and you would write this down, like this will work 100.0% of the time. You want a y-intercept? Go find all the x's and change them into zeros. So look at my yellow circle up on the TV. I'll tell you what I told you 20 minutes ago. Go in that yellow circle and change all the x's into 0. What do you get?
2 times the day.
After you reduce. You only use the like first one for like the degree.
No, it's not. No.
Yeah, it is.
So go inside the yellow circle and change all the x's into zeros. You can't change anything into 0 because there aren't any x's, so the y-intercept is just 5. These are the easiest problems that are actually the hardest because there's so much stuff that we should be doing on the harder problems that isn't here, and it confuses us. So you're not alone that these horizontal ones are difficult. You're actually going to probably have an easier time when we get to a quote unquote harder problem. You'll see.
Zero.
The last thing we have to do is find the hole and ask ourselves, is there a hole? And do you know where holes come from?
There's a what?
Oh, yes, they do. They come from what we canceled out. And so we canceled out something that would have had a bad guy of -2, right? So we know that there's a hole at -2, comma something. And the question is, how high is the hole? And again, this is confusing because normally I would say to you this function over here is the simplified function. And I would say to you again, for the third time, go change all the x's in that function into -2. And you say, I can't. Therefore, the output is just 5. The output of that function is always going to be 5. And there is all 5 answers. I'm going to help. Stay right here. Okay. I'm going to help Coop real quick and we'll come back and we'll do another one. Cooper, you still have a question? Like what, right now? You want to take one right now? Let me ask you this for a question. Let me pause this real quick. I can't wait. So what's our function?
F of x equals 4x squared minus 16x plus 6.
Oh.
Over 3x squared minus 1.
3x squared minus.
I feel like it should be easy.
It's fine. What do we do first? So we should pull a 4 out of the top. And if we pull a 4 out of the top, it's left as x squared minus 4x plus 4, which factors into x minus 2 times x minus 2. Okay, so we can agree that the top is 4 times a pair of x minus 2's. And there's no benefit in this case to writing it as x minus 2 squared. I actually think that would be more harmful than good. Having all the factors out in the open is beneficial. So normally nerds like me are like, you should write it using an exponent, but in this case, leave it out. And then on the bottom, if you pull out a 3, you're left with x squared minus 4, which is a nice classic difference of 2 squares. So it goes into 3 times x plus 2 times x minus 2.
X minus 2.
So you're good with the factoring, I guess, is what I want to know. Okay. So yes, what we're going to do is we're going to cross these off. And then we're going to take a quick moment and we're going to rewrite the function for future use in its simplified state. So we're going to rewrite the problem as f of x equals 4 times x minus 2 over 3 times x plus 2. Are you still with me? Okay, now it's time to go and do what we were intending to do from the beginning, and that is answer all the dumb questions. So here we go. Is there a horizontal asymptote?
Yes.
Where? So at y equals 4/3, I agree. Is there a vertical asymptote? Where? That is correct. And so the thing is that this one, I'm going to circle it in purple, this one survived the crossing out. And I'm kind of also talking to Emma right now, so just bear with me here. It survived. It didn't have anyone to cross out with, but it can make the bottom equal 0. If you put -2 into that purple egg, -2 plus 2 is 0, and there's not a darn thing we can do about it. And that's why it's a vertical asymptote. Nice job. Moving on. How do we find an x-intercept?
Wait, it's not equal.
Right, so I'm going to go over here because this is the better version of the top. And so I'm going to make it equal 0. And the only way to do that is to use x equals 2. So there's an x-intercept at 2, 0. But there's not really.
Oh, because there's. Oh.
I have a feeling that's probably where you missed it. So, and you watched me almost do it in the lesson yesterday, that it's really easy, but the whole comes in and says, I'm going to take the place of that x-intercept because I don't exist. There's no function value at 2. Is that what you did?
Yep.
Let's make sure everything else is good. So what did you get for your y-intercept? So if you put 0 in place of all your x's, that's -8 over 6. It's beautiful. So your y-intercept is 0, -4/3. And then finally, this is where I think you probably got the hole right. You just didn't see how it kicked out the x-intercept. So where's the hole? So that's at 2, 0 is correct. And do you see the contradiction right here, how these two things are the same? And if an x-intercept and a hole get in a fist fight, the hole wins 100.0% of the time. If a function's undefined at a number, that wins. So for x-intercept, you need to change it to none. And everything else will be fine. Yeah, it'll do it, eh? Do you want to do another one? Okay, good. Hang in there, kid, okay? I know it's overwhelming sometimes, but it'll be fine. All right, so you want to read it to me?
X minus 16 over x plus 4.
So, of course, you know that we have to factor first. So how do we factor that? Nice job. Now you're back in your fighting form. I appreciate you doing great. And then on the bottom, I agree. Pull out x, and what does that leave? Okay. So we're going to find ourselves again in a situation where things are going to cancel, right? And so what we want to do, and I'm just going to be bossy about this, this will help you, is I want you to cross these off lightly. Don't kill them, but leave them so you can see them. And then rewrite the function down over here as f of x equals -4 over x. What we want is we want to keep the old one laying around so we remember that there's a hole, but we also want to see the new one so that when later we have to do math, then we have an easier version of the function to work with. And quite frankly, if you're looking for a hole, the last step, and you use the one that has the purple, it won't work because you'll get 0 over 0. So it's important to keep old guy and new guy kind of both where you can see them. I'll be right with you, okay? So let's do horizontal asymptote first. And this is, I know, hard, but is there a horizontal asymptote? And if so, where? Good try. Here's when that would be true. Here's when I would say, yes, that's true. Watch what I'm going to do with my yellow pen. If that were x squared, then you see what that would do is it would match up the degrees so they're the same. When the degrees are the same on the top and the bottom, that's when we defer to the numbers in front. But because the x's aren't the same, then we have to go to one of two other scenarios. Are you ready? So here's what you need to know. If it's smaller exponent over bigger exponent, your horizontal asymptote is at y equals 0. Got it? Write that down for sure. If it's bigger exponent over smaller exponent, then there is none. There is no horizontal asymptote. Does that feel like a little more clarity to you on those? There are 3 situations. If they're the same, that's the one you had a minute ago in your mind. If they're the same, then you look at the numbers in front. But when they're not, then it's just going to be a comparison game. If they're the same, then you defer to the numbers in front.
You said
Because of
If there's more x's on top, there's no horizontal asymptote. Okay.
Put it in its 3 halves.
I think all the conversations, the sticking point tends to be the horizontal. So you're not alone. So anyways, let's talk about this one. Where's the horizontal asymptote? Correct. And so we just say at y equals 0. Good so far? Okay, and this is, I know where you had some stress, but I think you're doing better. Vertical asymptote. Now you can make the bottom of the fraction equal 0 post reduction. Yes, because look down here. Look down here. Good for you. That's see that X, he survived, huh? He didn't have anyone to cross out with. And if you put 0 in place of him, he makes the bottom equal 0. There is a vertical asymptote at X equals 0. Good job. It's any way I can make the bottom equal 0 after the reduction has been done. After things have been canceled. All right, let's talk x-intercept. And again, this is where you really want to write down just to tell me what to do kind of thing. To find an x-intercept, you have to make the top of the function equal 0. I agree, because there's no variable up there. So you say to yourself, how can I ever make a 4 equal to 0? And the answer is you can't. So there is no x-intercept. So for x-intercept, we would choose none.
I don't know, something that X plus one.
See? So x-intercept, you look at the top, make it equal 0. But notice we're not looking at the top of the original guy, right? Because that's where you could say, if I scroll back up and we look at this top, you could say, yeah, if I put -4 in there, I can make the top equal 0. But we're going to get to that guy in a little bit, right? That's why it's important that we focus on the post-reduction function. Right. Everything else, not everything quite. There's one more thing we got to talk about up here, but almost everything revolves around the fixed guy, the better guy, right? Okay. So now let's go look at the y-intercept. How do you make a y-intercept? Write this down. To find a y-intercept, you put 0 in for x. You got that? So here comes a question. If you take the function that I have circled in red, the good guy, and you put 0 in place of x, what do you get? So what do you get? You can't divide by 0, so what do you get? It's undefined. So what do you get? What's the y-intercept? Correct. So all the signs are just pointing to none. There is no y-intercept. And I'm going to show you this graph on Desmos in a second, and you can kind of see why all this is if you're interested. It's nice to see the graphs and kind of connect the dots and say, so that's why there was no y-intercept. So that's why there was no x-intercept. It's really interesting stuff, I think. Finally, we have to do the whole. And the whole starts like this. The whole is a two-step process. You start, first off, you go back and look and say, did anything cancel? And the answer is yes. So we know there's going to be a whole, and the x coordinate of the whole is going to come from the thing we canceled. And since it was x plus 4, we're going to put -4. And then where are you going to find the y coordinate for the whole?
This equals 0. This is multiplied by 0.
Nope. Where do you put it to find the y coordinate of the whole? You got to put this -4 is just sitting there like it's all amped up, like put me somewhere so I can help you. Like you got to find the output from my input. You put it right there. Plug it back into the simplified function again. It would be 1. If you put -4 right in there, it's -4 divided by -4, which is +1, and there's your whole, and you are done. And I don't have time to graph it with you because I got a couple more questions. So, Brinley, I know you've been waiting forever. You still have a question, Bryn?
Yeah. For that vertical asymptote, if it's x times 3x minus 2.
Does the 3x minus 2 cancel with anything on top?
No.
Does the x?
My thing says -5x times x minus 3.
I'm sorry, start over. Say again. What is it?
-5x
Okay.
times x minus 3.
So that's the top?
Yeah.
-3 over.
X times 3x minus 2.
You're sure your factoring is good? Okay. So this is an interesting one. The first thing that you need to note is that this x and this x cancel out. because those are factors, right? So if you're a factor, if you're multiplying, you're a factor in your open game, it's open season on factors. So we already know later on down the line that there is going to be a hole at 0 something, because 0 is what you could put in place of those x's I just murdered to make them equal 0. Are you with me so far? Okay, so we'll get to that later on. So let's talk horizontal asymptote first. Is there a horizontal asymptote? Yes. So it's y equals -5/3. And is there a vertical asymptote?
That's what I'm trying to find.
I'm sorry, and I know that this was your original question. The answer is yes. It's at x equals 2/3.
How do you-
Because if you set 3x minus 2 equal to 0, which is really the ultimate goal, then you just add 2 and divide by 3 and you figure out. Is that your only question? Okay.
What do you do when you get down to the bottom?
Oh, you panic? Go get a drink of water, maybe. Okay, well let's do your problem real quick.
2x squared plus 5x.
2x squared plus 5x plus 3.
You probably get why.
Can we please get Dakota Murphy and Zilphia